Good morning. Today we'll be seeing about B tree. This B tree topic is covered both in database management system as well as data structures. I'll be discussing a problem on B tree. Before that, we'll see few properties on B tree. So the first one, B tree, it is also called as balanced M-weight tree. So B tree, it is also called as balanced M-weight tree. So this M stands for the order. Okay. So this M stands for the order of the tree which is given. It can either be 3, 4 or 5 depending on the question which is given there. Okay. So this is M is the order. Then second point is generalization of binary search tree. Generalization of binary search tree. So the meaning of generalization of binary search tree is, in binary search tree, the root node will have a value and the left child node will have value which is lesser than the root node. Okay, so if it is going to be 50, the root node is going to be 50, the left child node will maybe we'll have it as 10, and the right child node will have a value which is greater than 50. So we'll have it as 100 here. Okay, so this is the format of binary search tree. So the same format will be followed in the B tree also, but there will be one difference here. According to the order, okay, if the tree is going to have order M, then the child will be M value and the keys in the node will be M minus 1. So we'll discuss that in detail. Keys, that is the values in the node, okay, that will be M minus 1, M minus 1. So if the M is going to be 5, the number of keys in that node will be 4, okay. So the keys in the B tree will be M minus 1 and the child in the B tree will be M, okay. So for example, if we have 3 keys for a B tree, then the number of children that node can have is 4, okay. Maximum is 4, not more than that, okay. Next, one important point about B tree, all the nodes should be on the same level, that is the leaf nodes. For example, I am going to construct a tree. It can be like this. If a normal tree, if you take a tree, it will be like this, okay. But in B tree, you cannot have like this. The leaf nodes should be in the same level, okay. So the bottommost node should be in the same level. So it should be the leaf nodes should be on the same level, okay. And one more important property of B tree is, whenever a tree is created or if you are going to insert a value, those creation has to be done on the leaf node. These values cannot be inserted directly on the root node or on the internal node. So these are few properties of B tree. The first one is it should be a balanced tree of m value. So if the key value is going, if the order is m, the key should be m minus 1, and child should be, that is the number of children for a particular key should be not, it should not be more than m values. Then whenever a value is inserted to the B tree, it should be inserted from the leaf node, okay. And this is how it should be denoted. The B tree should be denoted like this, okay. So for example, if the key value is going to be 3, I'll be denoting the node like this, okay. So these divisions are links, and if the key value is going to be 3 for order 4, then it should be like this, okay. So 1, 2, 3. It can hold 3 key values at the most, minimum 1 and maximum 3, not more than that. So this is the format of B tree. And one more thing is, whenever the values are inserted, it should be in a sorted manner. As I told you, it should be in a sorted manner. So I cannot insert it as 2, 1, 3 or 3 to 1. It should be sorted and the values should be inserted in order, okay. And if I don't have place to insert the values in the leaf node, then I should find the middle element from these values, and that middle element has to be moved to the parent node, okay. So here I'll show you how we'll do that. We'll discuss a problem based on the B tree. Then I'll tell you how we are going to split the node and then move the middle element to the root node. That's what we are going to do now, okay. So hope you are clear with the properties of B tree. It is a balanced tree, generalized format of binary search tree, which has the left value will be lesser than the root value and the right value will be greater than the root value. The keys will be, if the order is going to be 4, m minus 1. So 3 keys, and the number of children for 3 keys will be maximum of 4 children, and the insertion should be done only on the leaf node. It cannot be inserted in the internal node or in the root node. But if there is no space in the leaf node, then the values can be pushed up to the parent node if that element is a middle element, okay. So we'll see step by step. So we'll solve this problem step by step. Make sure you follow all these properties while solving this problem. So here is the question. Construct a B tree of order 4. So the m value here is going to be 4, okay. So the m value is 4. So if the m value is 4, then the keys will be m minus 1, which is 4 minus 1, 3, with the following set of data: 7, 10, 1, 23, 5, 15, 17, 9, 11, 39, 35, 8, 40, 25. So here I have 3, 6, 9, 12, 13, 14 values to be inserted in the B tree. Okay, so we'll do it step by step. So in the first step, what we are going to do is, step 1, insert element 7. Insert element 7, okay. So since the order which is given here is 4, maximum key element will be m minus 1, 4 minus 1, so key element will be 3, okay. So we'll draw a B tree with key 3, and insert 7 in the first position. So this is the first step of this problem. Next, we are going to insert the value 10, okay. So this is very simple. Since 10 is greater than 7, it can be just inserted in the second place. Okay, so that will be your second step. Seven and 10 will be inserted in the second place. Okay, so third step will be insert the third element is 1. So here, before inserting 1, we should see whether the values are in the sorted order. So if I insert 1 here, it is not in ascending order. So I should move 10 here, 7 to this second position, then I'll be able to insert the value 1 in the first position. Make sure the values which you are inserting is in the sorted manner. So I'll insert 1, then 7, then finally 10 will be moved to the last place. Okay. So now fourth step, we'll move on to the fourth step. So what is the value to be inserted in the fourth step? It's 23. Okay, we are going to insert 23. But to insert 23, this node is full because the maximum element it can hold is only 3 and this node is full. But we are going to insert 23. So how it can be done? So 1, 7, 10 and 23. Okay. So this is where I'll have to insert 23, but I don't have place. So I'll have to split the node and move the middle element to the root node. Okay. So I should find which is the root node here. I have 4 elements. Either 7 or 10 will be my middle element. If you are going to take 7 as the middle element throughout the problem, make sure that you take the leftmost element as the middle element. If you are going to take 10 throughout the problem till the end, make sure that you take the rightmost element as the middle element. So now I am going to take 7 as the middle element. So my middle element will be the leftmost element and I'll be doing that till the end of the problem. Okay. So I'm going to push the element 7 to the root node. Before that, I'll be splitting this node into 2. Okay. So we'll do that in step 4. Seven will be moved to the root node. 7. And to the left of 7, I should have the value 1, which is lesser than 7. So you will just have 1 alone because the other numbers are greater than 7, which is 10 and the new value to be inserted 23. Okay. So that will be on the right side of 7. 10, 23. Okay. So this is how we will split the node and move the middle element to the root node. And so here you can see whenever a new node is there, each node will have maximum of 4 children. So here you can have one child, here, here, here and here, and make sure all the leaf nodes are on the same level. So till here the leaf nodes are on the same level. So we'll move to the next step. So We have completed till 23. Now we are moving on to number 5. Okay. So insertion of 5 in the 5th step. So 5 should be inserted before 7 and after 1. So I can insert 5 here. You need not swap anything, just do the insertion alone in the leaf node after 1. Okay. One is already there on the left hand side of 7. Now I'll be inserting the value element 5 after 1. So 5 is after 1 but before 7. On the right hand side of 7, we just have 10 and 23. Okay. So in the 6th step, I'll have to insert the value 15. So 15 has to be placed after 10 but before 23. So 23 can be moved to the 3rd place and 15 can be placed after 10. Okay. So just move the element 23 and place the value of 15 in the 2nd position. So these values will remain the same, but we are going to just do a change in the rightmost element. So 23 will be moved to the 10 will be there. Then the new element which is going to be inserted, that is 15, will be placed in the 2nd position, then followed by 23. Since the B tree, balanced tree, should be in the sorted manner, we are moving 23 to the end and we are placing the value 15 in the 2nd position. So this is how you will do. Now after 15, we are going to insert the value 17 in the 7th step. So to insert the value 17, 17 should be inserted after 15 but before 23. So now the node is full. So what can be done? So it will be like this: 10, 15, 17 and 23. Okay, but the node is full. So the value 17 cannot be inserted. Okay, so to do this, we will have to find the middle element and again move the middle element to the parent node. Okay, so here I am going to take the leftmost element as the middle element. Since 15 and 17 both are the middle element, I am taking the leftmost as I am following the same method from the beginning. So I will be moving the 15, the element 15 to the parent node. Okay, so after 7 I will be placing 15. Okay, and on the left hand side of 7 I have 1 and 5. And on the right hand side of 15, actually I have 17 and 23, but we have 10 also. So that should be placed in between 7 and 15. So here I will have a child which will hold the value 10. So it will just hold the value 10. because 10 is between 7 and 15, that will be here in between 7 and 15, and the remaining values 15 and 15 is here. 17 and 23 can be placed on the right hand side of 15. 17, then 23. Okay, so the new value 17 is inserted now. Okay, so make sure whenever the value is inserted, all the values are on the same level. So all the values are on the same level. Okay, so we have done the insertion till 9. Step 8, insert 9. Okay, so now also when you are splitting the element and moving the middle element to the root node, make sure you mention that. So split and move the middle element to the root. Okay. Next, in the 8th step, we are going to insert number 9. So 9 has to be inserted after 7 and before 10. Okay. So we can place it here. We can just move the value 10 to the second position and we can place number 9 in the first position. That's all. So no other changes. We need not split any nodes. So we'll just place 10 to the second position and we'll place 9 in the first position. So that alone is enough. Seven, 15. So the root node remains the same. And to the left of the 7, we have 1 and 5. And in between 7 and 15, now the new value 9 will be inserted. And on the right hand side of 15, we have the value 17 and 23. Okay. So we have completed till 9. Now the next value to be inserted is 11. So while inserting 11, it should be placed in between 7 and 15 and here after 10. So 11 should be placed here. That is the 9th step, insert 11. Nine, then 10, then 11. So 11 is placed after 10 and this value is between 7 and 15. Okay. So we have done the insertion till 11, next value is 39. So 39 can just be inserted after 23. So step 10 will be insert 39. Insert 39. Root node will be same 7, 15, and on the left hand side of 7 we have 1, 5, and between 7 and 15 we have 9, 10 and 11. Then after 15 the value 17, 23 followed by the new value 39. So now again make sure all the values are on the same level. The leaf node should be on the same level. So the 11th step will be insert 35. Insert after 39 it's 35. So 35 should be inserted between 23 and 39 since it has to be in sorted order, but 35 cannot be inserted here because the maximum element can be 3. So we are going to find the middle element for 17, 23, 35 and 39. Okay. Since we are going with the left element, 23 will be moved to the root node and it will be placed here. Okay. So we are going to do that in step 11. Okay. Seven, 15. Here the middle element which is moved to the root node is 23. So now on the left hand side of 7 we have 1, 5, next between 7 and 15, 9, 10, 11, 9, 10, 11, and between 15 and 23, so we'll have to place only 17 here because the node is splitted and moved to the root node. Okay, split and move the element 23 to the root node. So we are going to place only 17 here and the remaining 2 places will be empty. And after 23, place 35 and 39. 35 is the new element to be inserted and place 39 after 23. So here on the right hand side of 23, 35 and 39. Okay. So now The next step will be insertion of value 8. So the 12th step will be insert 8. Insert 8. So the value 8 should be inserted before 9 and after 7. So how we are going to do that? Here should be placed here, but there is no space. So it will be 8, 9, 10, 11, and the middle element will be 9 because we are going with the left middle element. So 9 has to be moved to the root node. Now 7, 9, 15, 23. Okay. So here, since there is no space, find the middle element, leftmost middle element. Again 9 is moved to the root node. Okay. So 9 has to be moved to the root node. So only 9 will be there. And on the left hand side of 9, we'll have 7. So only 7. And on the right hand side of 9, we'll have the remaining two elements, that is 15 and 23. And on the left hand side of 7, we'll be having 1 and 5. Then between 7 and 9, we'll have, okay, so on the right hand side of 7, we should have the value, new value, which is going to be inserted, that is the value 8. Because 8 is on the left hand side of 9, but on the right hand side of 7. Note that carefully. 8 falls on the left hand side of 9, but on the right hand side of 7. So only 8 will be here. And the other two places will be empty. Okay. So the remaining values 10 and 11 should be on the right hand side of 9, but left hand side of 15. So 10 and 11 will be here. 10, 11. Since we follow the binary search tree format, should be on the right hand side of 9, but on the left hand side of 15. 10 and 11. Then we have the value 17, which will be on the right hand side of 15. Then on the right hand side of 23, we'll have the value 35 and 39. So we'll check whether all the properties of B tree is satisfied. Yes, everything is there on the leaf node. The leaf node is on the same level, and the values which were inserted on the leaf node, but few values were pushed to the root node, and it is in sorted manner. Okay, also it forms the follows the binary search tree format, that is left hand side should be lesser than the root node and right hand side should be greater than the root node. So it follows that. Now the next value to be inserted is 40. Insert 40. So 40 can be just placed on the right hand side of 23, and we have a place here. After 39, 40 can just be placed here, and there is no changes for inserting 40. So the other values will remain the same. Seventeen to be kept between 15 and 23. So these values remain the same, and after 23 on the right hand side we have 35, 39, and now 40 will be placed in the 13th step. Okay, so the last step, 14th step, will be insertion of 25. So the 14th step, insert 25. So where 25 should be inserted? 25 should be inserted after 23 and before 35. But I cannot place 25 here because that's the internal node. Always the insertion has to be done only on the leaf node. Okay. So here if you see 25, 35, 39, 40. Okay. Since it exceeds the key value, we are taking the middle element, that is leftmost middle element 35, and we are moving it to the root node. Okay. Now, so split and move element 35 to the parent node. Split and move element 35 to the root node or parent node. Actually, we mention it as parent node, okay, to the parent node. So when the value 35 is moved to the parent node, it will be placed here and the node will split again. So you can see, I told you a node will not have more than 4 children. Each node will have only maximum of 4 children, not more than that. You can see that, okay. So 1, 2, 3, 4, maximum of 4, not more than that, okay. So we are going to split this node again and move element 35. Nine, on the left hand side of 9 we have 7. On the left hand side of 7 it's 1, 5. Right hand side of 7 it's 8. And on the right hand side of 9 15, 23, then the new element which is pushed, which is 35, okay. 15, 23 and 35. Now on the left hand side of 15 we have 10 and 11. And between 15, 23, just 17. Between 23 and 35, we'll have this 25, the new element which is inserted. Just 25 alone. And on the right hand side of 35, we'll have 39 and 40. 39, 40. Okay. So here you can notice it satisfies the B tree properties. It is balanced and it follows binary search tree format. All the values to the left hand side of the root node is lesser, and to the right hand side of the root node it's greater. And you can see here we have 3 key values with 4 children, 1, 2, 3, 4, not more than that, okay. Maximum it will have only 4 children. So it follows all the B tree properties and it is sorted, it is in sorted order. So this is an example for B tree with order 4. Okay. So if the order is going to be even, you will have the problem in choosing the middle element. So go either with the left middle element or the right middle element and follow the same throughout the problem. Okay. Thank you.